I know pretty well, happens to be my sister, and her name is Nujud Moranci. And she is a systems engineer with an extensive background in human space flight and spacecraft at the NASA Johnson Space Center. She is currently the chief of the Exploration Mission Planning Office, which is responsible for the team of engineering, designing, developing, and integrating NASA's human spaceflight portfolio beyond low Earth orbit. These missions include planning for the Orion Multipurpose Crew Vehicle, Space Launch System, Exploration Ground Systems, Gateway, and Human Landing System. She's responsible for ensuring the mission design, trajectory, and objectives can be successfully met by the programs and vehicles for successful human spaceflight operations. Could go into even more in depth, but I think I'm going to pass it off to her to actually introduce herself a little bit.
All right. Hi. Thanks, Samira. Good to see you. So we go way back, obviously, and I'm glad I could be here today. It's really fun to do these things. We do outreach all the time, and this is a little bit different, but in COVID, we're being creative. So we've actually been taking outreach to a lot of schools, Girl Scout clubs, whatever, and this is another fun way we can reach out and explain more about what's going on at NASA while we're all in this weird situation, as I come to you from my dining room even, right? So even NASA is not immune from teleworking and being remote right now. So I'll just go ahead and get to the charts. There's a lot of stuff in here. I'm just gonna talk through things. You can look at it at your leisure. If you even have questions, you can send them to Amira and she could pass them on to me after the fact. So even if you think of something a week from now, just give us a buzz and we'll answer it. So if you want to start the chart, Samira, there's a video right up front.
Sorry, I was on mute. Can you guys see my screen?
We've got the presenter view. Can you swap display?
Absolutely. Okay, are we good?
There you go. Yep, we can see him now. Thank you.
Ignition sequence start. All engines are.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking, and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
Oh.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers The star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this goal. We are NASA. And after 60 years, we're just getting started.
All right, so I like to start with that because it's just a fun overview, and one of the really important things that we're doing is we really are building on all of the knowledge gained over the last 50 years at NASA, almost 60, and spaceflight even before that, before NASA existed. And some of that is actually two folks in your community, Stanley and Suzanne Jones, who are in Arizona, formerly supported the Jet Propulsion Laboratory. So even some of the folks on the call today, those are the folks that have laid the groundwork for where we are. And so a big thank you to them. And as we go forward, you know, your contributions continue to this day. So one of the first things is Artemis. So when we are talking about Artemis, this was intentionally chosen for the name because Artemis in Greek mythology is the twin sister of Apollo. So whereas we're all familiar with Apollo going to the moon, Artemis is the next step. So when we talk about Artemis, there's actually a whole bunch of vehicles, and I'm not going to get into a ton of detail on all of them. But Artemis is really a collection of programs that are needed to go to the moon. So the first thing, the most obvious thing is the rocket, which is the Space Launch System. So that is based a lot on shuttle technology that's moved forward. So the orange tank should look familiar from the Space Shuttle program, very similar to those, but bigger actually. And the side, the solid rocket boosters, the big white boosters on the side. So the Space Launch System is our rocket. Orion is the capsule on top. So this is where Apollo was, very similar in design, a capsule on top of the rocket to what Apollo did. There's a lot of reasons for that, mostly being safety and performance. But that is where the crew will be during ascent and on the trip to the moon, and then as they come back to Earth and splash down. And then all of this launches from the Kennedy Space Center, just like Apollo did in Florida. So that is the Exploration Ground Systems, which is the program that's building the new launch pads, the new Launch Control Center, all of the upgrades needed to go along with SLS and Orion. So I'm going to try not to use too many acronyms, but if I slip up, this is what they mean when I'm talking about it. So let's go to the next slide. Unlike Apollo, though, when Apollo launched, it launched with the capsule and the lander all on the same rocket. We're doing things a little bit differently, and there's a bunch of reasons for that, but a lot of it is about trying to get to the South Pole on the moon, which is actually harder to get to than where Apollo landed around the equator or the middle of the moon. So we're launching the human landing system separately. So on the right in the picture are all of the pieces. That's the lander that would actually go down to the moon. That's just a reference right now because it's still in competition. So there's 3 companies vying to build it. So that it'll end up looking different by the time we actually land there, but there will be a lander that launches separately and is waiting in lunar orbit for the crew when the crew comes on Orion out to the moon. And then the gateway is going to be an orbiting outpost. So this is like a small miniature version of the International Space Station, but in lunar orbit. So when the crew gets there, we'll have a gateway or an orbital space station and a lander to take them down to the moon. So a lot of what we're doing is because we're trying to be able to build up pieces so we can keep exploring the moon over many years. Whereas Apollo was very expensive and flags and footprints, right? Get to the moon. For reasons at the time, mostly the space race. It was a very costly program, but it was get there, land, and come home. And even that was incredible with the technology at the time. But we're trying to set it up so that we can keep doing this for many years, which is why we have a different choices and an orbiting laboratory. So if you go to the next slide. And then when they get down to the moon, so here's another picture of what would be the lander in the background. We have other programs right now, which is a new set of a new suit. So this is the Exploration Extravehicular Mobility Unit. That is a fancy name for the spacesuit. So on Apollo, really the astronauts actually looked like a marshmallow man. They couldn't move very well in the suit. It was like a big balloon that blows up, and so it's really hard to move in. The new suit designs are designed so that the astronauts will be able to have much more mobility, so that like the shoulders have a joint in them so they can reach for things, and it'll be a lot easier for them to do more complex tasks. So they have a much better suit that's being designed to support them doing moonwalks in the future. And then we also have a lot of other equipment that, as we're trying to build up for a long-term exploration, we are already working on a lunar terrain vehicle, or a car. It's a moon car for them. And then we'll be able to put down potentially future systems like power systems or habitats. So trying to do this for a long-term exploration, there's a lot of different pieces that have to come together. So let's go to the next slide. And this is where we're really building on all that exploration. So NASA's been around for 60 years. A lot of it was started with the intention of going to the moon, and it did. And so as I've been saying, right, we're trying to build up a sustainable capability for the moon so that we can do this many times, and also test out the technologies and the equipment we need to eventually go to Mars. So exploration is very difficult. So if we can start testing things on the moon, all of that will eventually lead forward into Mars exploration, and hopefully even more after that. So all of this is we're trying to do. We're building on all that Apollo experience so we can go further into space. But that's why we always get the questions of why is this different than Apollo, and why not just repeat Apollo? So that's where the bulk of the rest of the talk I was going to give, which is what is the difference between Apollo and Artemis? So let's go to the next slide. And so a lot of the difference comes down to why. So when Apollo went, it was to commit to go to the moon and return safely to Earth. There wasn't any constraints on where on the moon. There wasn't any talk of science. There wasn't any discussion of how long they needed to stay. And because of that, it really chose the easiest place on the moon. And the easiest place is at the equator. Now, when we go to the moon, we're trying to make it sustainable and then be able to send astronauts onto Mars. So that really drives a lot of differences in our mission and the equipment and vehicle designs that we're coming up with. So many things stay the same. The physics stay the same. The capsules look very similar, but some things about the mission are very different. And so that's where we can talk some of the differences between Apollo and Artemis. So next slide. So when Apollo went to the moon, it launched. It did a circle around the Earth a couple times, and then it headed out to the moon. And then as it got to the moon, it entered a low lunar orbit and then went down to the surface of the moon on the equator. And then to come home, it basically reversed the process, went back up into low lunar orbit, met up with the command module, and then returned to Earth on a direct entry. So relatively simple design, and it's all sort of in plane. And that's an old mission map from the 1960s shown there that I animated. But that is the mission in a nutshell for Apollo. If you go to the next slide, we're using a different orbit, but the same thing. We take off from Kennedy Space Center, go around the Earth, and then Orion and SLS head out to the moon, meet up in the gateway orbit with the gateway and the lander. And then the lander will actually take the crew down to the south pole of the moon. So this, we're headed to the south pole, and then it reverses it, heads back up to the gateway orbit, meets up and docks. The crew would spend a few days back in the gateway and Orion before headed back to Earth. So we're using very different orbits. We're in this, it's called a near rectilinear halo orbit. Really the point there, rectilinear means perpendicular essentially. So whereas Apollo was all in plane at the equator, we're using an orbit that's out of plane and hangs down below the south pole of the moon, and that's to make the descent down to the south pole more advantageous for us. So one of the big differences in Apollo and Artemis is first the rendezvous with the pre-deployed lander that's already out at the moon, and then the orbits we're staging in around the moon. So next slide. And so then this, I'm not going to talk through all the technical details here, but like I was talking about, because we're using a distributed launch, we're launching more than one rocket. So you'll actually, Apollo launched everything on the big Saturn V that you're familiar with from video clips in the 19th. Launching Artemis first on the rocket, the SLS rocket. So the crew would take off on the Block 1, and then we'll eventually upgrade it to a Block 1B. But a lot of this allows us so that we can have a little bit more performance and flexibility. And then the actual lander is bigger than the Apollo one out in the staged at the moon, so when we meet up with it. So there would actually be a series of flights before the crew launches, putting the pieces up around the moon. Some of the things we have more flexibility on now than they had in the 1960s essentially comes down to some of the other technologies. During Apollo, they had to stage Navy ships out in the Atlantic Ocean and an airplane in the Pacific so that they could get communication with the Apollo spacecraft while it was still around the Earth. We can take advantage a lot of space-based satellite communication now, so-called the TDRS satellites, which the military runs for the country. We also buy time on it, and that allows us to talk to Orion and the rocket during all of the launch and Earth operations. So we actually have a more complete communication capability, which gives us a little bit more flexibility in the launch than they had in Apollo, because we have modern satellite technology to go with it. So next slide. During transit, so here is a picture of Apollo and Orion nose to nose, if you will. You'll notice the capsule shape is very much the same, but one of the big differences in Apollo and Orion is Apollo was limited to a shorter mission because, like they said, they didn't have to go for long periods. It was just to get people down on the moon and bring them home again. So the total mission in Apollo was only about 13 to 14 days. That's the longest it could be in space for, because it was using fuel cells, which use chemicals to create electricity. So you can only stay out in space for as long as you can have power on your spacecraft. For Orion, we've actually prioritized it. So even though the shapes are very much the same because physics didn't change, we've prioritized for longer missions. So we're using solar arrays and modern solar array technology to be able to create electricity. So that's free power from the sun. So our missions can be much, much longer. So we can actually put 4 crew members in. Apollo was 3, and they can fly for as long as 3 weeks just in the food and water supplies that Orion brings on its own. If you have something like the Gateway there with more consumables, because we're using solar arrays, Orion can actually stay there for 6 months right off the bat. And if we want to extend it, we could get Orion flying for a year, 2 years if we needed to. And it's just a matter of having the commodities for the crew, food and water, because everyone likes to eat and drink. So one of the big changes that we have is really using solar arrays instead of a fuel cell for power. Actually adds a ton of flexibility to our mission design and the overall capabilities, because we're not constrained to electrical power running out. And that's the same thing you'll see on Gateway. It has huge solar arrays. So the things we're able to do now with some of the modern technology there allows us to have this sustainable lunar exploration that really wasn't possible in the 1960s. So next slide. And then, like I mentioned, one of the other big differences, right? Apollo was just get to the moon any which way you can, which was a huge challenge in and of itself. In the top left picture of the moon there, so what you're looking at is the near side of the moon, the face you see when you go outside, and the white dots are all of the places the Apollo missions landed. So you can see they're very much in the middle of the moon, and number 4 and 6 at the top there were the most challenging ones, where they got furthest away from the equator. We are trying to land on the south pole of the moon, and one of the big reasons for that is because there are permanently shadowed craters where there is no sunlight. So if we're going to find water and other exotic minerals and capabilities on the moon, the most likely place we'll find them is at the south pole in those craters that never see sunlight. So, but getting to the south pole requires a lot more performance, in this case gas, right? So it takes a lot more of the rocket engine thrust to be able to get to the south pole and stay there, and then stage to be able to come home again. So we're challenged a little bit more than Apollo, for good reason. We need the challenge to get down to the moon. And when we send the crew, even on the first flight, we're going to send them for about 6 days onto the South Pole. So Apollo, the maximum surface stay on Apollo was 3 days, and that's a lot due to the timing on the electrical power systems. We are going to stay for 6 days at a time, and they return to Gateway. And overall, the mission length when we launch Artemis for the crew for a lunar landing is about 30 days. So they are very ambitious missions, and all of this is because we're trying to hit the South Pole and build up for long-term sustainable capability. So the missions will be about a month long, when we send the crew there, and they'll spend about a week of that month on the surface of the moon. So very exciting in that regard. Next slide. And then one of the other things, so this is just one of the really interesting things about it, a little bit more technical. When Apollo landed on the equator, you get the sun that's generally overhead, and then they just had to, which day they landed mattered for where the sun was, because as the pilots, and you're piloting the spaceship down to landing, you need the sun behind you so you're not staring at the sun being blinded by it. So a lot of the piloting on their lunar surface axis around the pole was about the sun being behind them during their approach. When you land on the South Pole, the sun is actually never more than about 5 degrees off the horizon. So if you're looking out, it was really low right there, and it'll cast really long shadows. So using the 1960s technology, the crew probably wouldn't have been able to land at the South Pole because they have to do it all manually, and the lighting conditions are so strange that you probably wouldn't have been able to do it. But what we can do now with modern technology is we can use what are called flash LiDAR systems, which is kind of like a radar that shoots out images onto the surface and can create a map, a three-dimensional map in the computer for where all the terrain is, the hazards, the boulders, and stuff like that. So we'll be able to use advanced technology for the vehicle to be able to land itself with the crew monitoring it and being able to take manual control if they need it. So being able to actually land on the South Pole is something that's been enabled by modern technology and probably wouldn't have been possible back in the 1960s. So now that we understand a lot more of the South Pole, all of the interesting science things that are there, which you'll hear about next week and the week after, we'll be able to actually achieve that through our engineering and the modern technology for landing there. So a lot of the things that have changed, a lot of space flight's the same, a lot of it's changed, and that's the enabled of the things we've just gotten smarter with over the last 60 years. So next slide. And then coming back to Earth isn't much different between Apollo and Artemis. On the top left there is a picture of a naval aircraft carrier which recovered the Apollo crews. So the Apollo crews would splash down in the Pacific Ocean, the Navy ship would be standing by, and the helicopters and the divers would get out and get the crew safely. We're doing pretty much the same thing. Orion will splash down in the Pacific Ocean, only this time with Orion, we're actually using computers, and we can fly Orion back to a specific landing point. So we can land, we're going to land just off the coast of San Diego. So we can actually touch down within 2 hours of the coast. It's a guided entry. So that means Apollo landed way out in the middle of the ocean just because that's where it was coming in. We're using this guided entry to get really close to the coastal United States, make it much easier to pick up. And you can see in the bottom right picture, that's actually a naval well-deck ship, an LPD. And that thing is actually, the bottom end of the ship will actually sit down in the water. So for our recovery, they sink the back end of the ship a little. They're just going to tow Orion right into the back end of the ship. They close the door and pump the water out and lift Orion up out of the water, and the crew will be able to get out right there on the deck of the ship. So a little bit cooler technique with the modern ships that we have. And the other thing we're challenging the Navy to do is to be able to pick Orion up in the dark. So for Apollo, they all only landed in daylight, which cut out some of the times they could launch the mission because they needed to make sure they had daylight for the recovery. We're challenging the Navy to be able to pick us up at any time, and that opens up more opportunities to launch. So when you're trying to do things over the long term, we need to have more flexibility in when we launch to keep missions going year after year. So this is one of the Navy challenges, and this is a picture of one of their training sessions at sunset where they were practicing picking Orion up in the dark. So it'll be really cool when this happens, right? We've got a lot of partners in this, including the Navy. All of these things are, a lot of these are to upgrade safety or to upgrade flexibility for our mission designs in the future. And next slide. So ultimately, a lot of the things that change still stay the same. There's a picture on the left of Neil Armstrong, or that's Buzz Aldrin on the moon actually in that picture. And on the right is a graphic of what it might look like in the future. So we're trying to enable the South Pole exploration and sustainable design. There's a lot of similarities, the capsule shapes, the rockets, things like that, but a lot of things have changed, and it's that incorporation of modern technology to reach new challenges. So, and if you go to the next slide. And a lot of this, so as I've been talking, I'm talking mostly about what is called Artemis 3, which would be the first mission down to the surface of the moon. But leading up to Artemis 3, we have a series of missions, just like Apollo, starting with Artemis 1, which should be actually less than a year from now. It'll be next summer in 2021. Artemis 1 is going to launch, and that's an uncrewed flight. So again, with modern technology, we can fly the whole mission without people on board to ensure everything's safe. So this is basically our dry run of the whole launch for SLS, the rocket, and Orion, the spacecraft, will happen next year. And then we'll launch a mission with the crew called Artemis 2, which is going to be a little bit different design, where we're just going to fly by the moon and come home. So that'll be the first time people have left low Earth orbit since 1972. That'll be the first time in my life that people have left low Earth orbit. And then eventually we build out, like I said, we launch all the things out to the moon and pre-position them. The gateway will have some pieces there. The lander will have some pieces there. And then we'll fly Artemis 3, which will actually put people down on the surface. And in the meantime, there's a ton of scientific missions, rovers, things like that, that are going to be sent to the moon. So in the next 5 to 6 years, we're actually going to have a whole ton of things going on. I hope you hear about them all in the news, because it's going to get pretty exciting pretty quick with the things NASA has going on. So next slide. And I'm just going to spend a little bit on some pictures. So as I said, we have launches that are ready for next year. So that means we have a lot of hardware that's already ready for the most part, and in its final stages of being built. In the center there, that is the Orion capsule that will launch next year. It is almost completely done. They're literally installing the last few things and the fairings and the pieces to button it up, and then it'll be ready for launch and to be put on top of the rocket. There's been testing going on, so on the top right you can see the abort motor that will be on top of Orion when it launches, doing a test. And then the back end of the SLS rocket is there with the big 4 engines on that. So next slide. The ground systems at the Kennedy Space Center have been upgraded. So this is a lot of the work going on there right now. And in the center is the big crawler transporter. So just like that is literally the same crawlers used for Apollo, but they've been upgraded with newer motors. And the same ones used for the space shuttle will be the same crawlers now that pick up SLS and Orion from the vehicle assembly building and roll them out to the pad and get them ready for launch. So when we say we're building on the last 60 years technology, it really is true. A lot of it, in some cases like this, is the exact same hardware. So next slide. And as I mentioned, there's been a lot of tests going on. So in the center there was a test in July of 2019, so just over a year ago. And that was a test of the Orion abort system. So this was just a Minuteman rocket that they put Orion on top. And it was a test to make sure that the abort system, so if something happens with the SLS rocket, the capsule will come off Orion and drop the crew safely into the Atlantic Ocean. So we tested that full abort system just over a year ago. So all of these pieces are being tested on the ground before they fly. Some of the sub pieces get tested in flight tests. So there's really been a lot going on for many years, all culminating in what will be the start of the Artemis flights next year. Next slide. And then lastly, the big Space Launch System rocket. So that's a picture of it in the structural test stand. So that's in Alabama at the Marshall Space Flight Center. So they actually, that is like a big can crusher. They built the whole rocket stage just like it would be in flight. They put it in this big rig, and it actually smashes it down with the loads it would experience in flight, so they can test to make sure that there's no weaknesses in it. And then this module, they actually broke. So they keep loading it up and loading it up to find out when it fully fails. So there are some good videos on the internet of that huge rocket stage splitting open. It tested exactly, it broke right where it was predicted. So that means all the calculations were correct. And that means we know the rocket's going to be ready to fly. And actually next month, the fully assembled SLS core stage, the big orange stage with 4 engines on the bottom, is currently sitting in a test rig at the Stennis Space Center in Mississippi, and it's going to be test fired for the entire profile like it will in flight. So with a test coming up in just a few weeks of the rocket, which will be really cool. It's all tied down to the ground, so it can't go anywhere, but it'll test the entire tankage and engine system so that we know it's ready to fly. So lots of testing going on and getting ready for flight. Next slide. I think I'm near the end. Oh, here's another picture. So just more pictures of SLS and tests going on. The Navy on the bottom right there, we've done a lot of recovery tests so that they can make sure that they can pick the capsule up and get the crew out on time. In the top left is the Super Guppy. So it's been flying equipment all over the country, bringing pieces together to Kennedy Space Center to get built. The cool thing about that airplane is literally the front of the airplane opens like a door and then you can slide things in it. So that's actually what you're seeing in the top left picture. And in the center is some of the welding rigs actually assembling some of the core stages of the rocket. So just so much hardware and equipment is in production right now. Next slide. And I think that's it. So I'd love to take questions. I hope I didn't use too many acronyms. It's a bad habit to break sometimes, but I'd love to hear your questions.
Thanks, Judy, Nujud, sorry. So we do have a question. Looks like this is coming from Meadowlark Senior Living in Lebanon, Oregon. And they're asking, are we looking at potential habitable moon bases as an eventuality? I know we're not there yet, but if we're planning on Mars eventually, will this be the Mars staging point?
Those are some awesome questions. So yes, we are looking at eventual moon-based habitability on the South Pole. So all of the equipment we're building is intended to be able to support that in the future. So we're looking, and there's teams that study this. Part of my team actually studies what are some of those strategic pieces and the elements we need next. And some of it is a base for the moon. So, and that's why I mentioned a habitat, power systems will be very important, and then rovers, including a pressurized rover, so the crew can go for even longer distances to do science and exploration on the moon. So yes, absolutely, we're looking to make a permanent moon base on the South Pole. First, we got to get there, and then we can start building the moon base out. So that's intentionally the progression. In terms of the Mars staging point, it's sort of. When we stage to go to Mars, if you actually put things on the surface of the moon, well, you've got to get them all back off the surface again. So staging for Mars will be in that gateway orbit, the big orbit around the moon. So part of the reason we can put the gateway there and have a little mini space station is that eventually we could put big pieces on that. So a big habitat that you need to go to Mars, the engines, the things like that. So staging for Mars will probably happen in an orbit around the moon, and then you take off from the moon from there. So there's a lot of things about the choices we've made for sustainability. So when we go, we can keep building on what we're doing. So the gateway you can think of as the precursor staging point for your Mars vehicles that you would eventually send. The moon base is just for actually we can test things we would take to Mars on the surface of the moon. But you wouldn't actually launch something from the moon to Mars just because it costs you more gas to get it off the surface again. But it's all comes together in the end. So great question.
So another one kind of follow up from Liz here is, will 3D printing technology factor into creating on-site items?
Awesome. Yes, this is a great question. So there actually is 3D printers on board the space station right now. So we can test things like that out on the space station, because doing things in microgravity or zero gravity is very different than stuff on the ground. So making sure 3D printing even works in space has been demonstrated for many years now on the space station. So we know this is something we'll be able to use as we go forward. Now, the small stuff could be like on the space station, you can print things and you could basically make a tool. So you don't have to bring every wrench in the system if you can just print the tool when you need it later. And that way you can maybe have to take fewer things. So there's a lot of things like that that build into it. And then when you actually talk about on the surface, there's a lot of discussion of, yes, using what's called in situ resources, or the dirt and the rocks that are already there to build. So there's lots of research and study going on for, can you build a machine that can build walls out of the dirt of Mars soil and stuff? And that way you can have, say, radiation protection built out of the dirt, and that's less stuff you have to bring with you. So 3D printing is a really incredible thing. going on. And I'd actually say there's a lot of 3D printing that goes on today. Things like, it's called additive manufacturing, is used in some of the parts on the Space Launch System rocket, where they put all the metal together and then you machine down a smaller piece. Instead of having to start with a giant block of metal, you can use a smaller piece to start with. So there's a lot of technology going on in the manufacturing and potential in space uses for 3D printing.
Great question, Liz. So one question came in from Majestic Rim in Payson, Arizona. They're asking how many men or women astronauts are training for the future missions?
So awesome. Right now, there's about 40 astronauts in the astronaut corps. I can't remember the exact number. We just graduated a class last year, or actually it was January of this year, and that was another 12 new astronauts. So all of those astronauts are already training. They're being sent to the space station. They're learning all the great things that happen there. Some of those astronauts may be the ones that we send to the moon. So they don't normally name crews for the missions until about 2 years before. So if we're going to the moon with people in 2024, 2025, we probably already have those astronauts in our astronaut corps, and I bet they're all rubbing their hands together, hoping to be the one that gets to go. So we're already training about 40 astronauts. When we send people to the moon, 4 people will go at the time, 2 will go to the surface, 2 will stay in orbit. But they're already being trained. They're actually a part of our teams designing the systems. So that way we're making sure we're making things that the astronauts will be able to use easily. Things like the new spacesuits, they're heavily involved in the engineering for. And there's another class that's in process of being selected right now. Applications were due this year. So, you know, a lot of the training is already going on, and a lot of the training they get for the space station is just as applicable to the future system. So yes, there's a lot of astronaut training going on.
I actually have a follow-up question to that one as well. If you're in the astronaut corps, what's some of the final criteria, or how do you get to actually go on a mission?
Cut out, I think, get to be an astronaut, basically.
Oh, sorry. Just as a follow-up to that question, once you're in the astronaut corps, what's some of the deciding factors for actually determining if you get to go on a mission?
Okay, yeah, that is a good question. So there's a lot of factors that go into it, and every mission that sort of needs all the different skill sets. So you need your pilot, your commander, you need, if you're going to send science, you want someone that's good at the experiments. Maybe one of the crew is a doctor. So I think when they're assigning the crews, they're trying to make sure they have someone for an expertise in all the areas. And one person may be an expert in 2 or 3, so your composition changes between the missions. And then I think the other really important thing, everything I know from working with them, is they make sure that the astronauts on a mission work together as a team well. These are high stress situations. When they go to the space station, they're there for 6 months. As we're all learning in COVID, when you're isolated with the same people for a long period of time, it can be very stressful. Little things start to irritate you. And then for the astronauts especially, they need to be able to respond well in emergencies and be able to work as a cohesive team. So the psychological piece of what makes a good team is really important in the astronaut program and how they assign them to missions. So we always talk about teamwork at NASA, not just in the engineering and the astronauts, but none of us do this alone. So that teamwork piece is incredibly important for them.
Great, thank you. We do have a question came in from Lassen House in Red Bluff, California. Is this for research or habitation later on?
So a lot of this, in sort of Artemis in general, is it does a variety of things. The big purpose is first science and exploration, but also when we do things at NASA, we're always looking for ways to partner with industry and bring the commercial economy along behind us. So it isn't just pure research, right? A lot of it is to drive the economy for the US, drive the space economy, which benefits humanity overall. So a lot of this, what we're doing, it is real engineering. We're really launching these things. It's not research per se, is that it's a paper vehicle. All those pictures I showed are real. So we're gonna launch this, and then we have lots of plans for what can follow. So there is research going on for the what can follow, how do you go to Mars and stuff like that. We know a lot about it, but we also know it's very hard. So not just research, but for real habitation as we build out there.
Great, thanks. So a question came in from, this actually came from Jill Berry, one of our regional directors who happens to be at Blossom Vale down near Sacramento right now. Nujud, thank you so much for sharing your passion and knowledge with us. What do you think is the most innovative concept NASA has developed in the last 20 years?
Ooh, that's a tough one. I'll just think one of the coolest things I've seen actually comes from our friends at the Jet Propulsion Laboratory, which is the Sky Crane, which is how they landed Mars Curiosity, the rover that was last landed on Mars. It was so big, they couldn't use the whole, like, just bounce it with a beach ball technique that they'd used in the past. So they built a crane that hovered over the ground and lowered the rover down on a cable and then cut the cable and crashed. But that Sky Crane, I think, is one of the coolest, most innovative ways that someone on our team came up to do with lately. And so it didn't come from us, but I think it's still one of the coolest ways something's been landed on another planet. So I like that one.
Thanks. So we have another one came in from, looks like Paula down at Lakeland Senior Living in Eagle Point, Oregon. What are the advantages to landing at the South Pole?
So the advantage to landing at the South Pole is to do science. So first off, we can get into those permanently shadowed craters where we might be able to find water. We might be able to find other interesting things that have been just trapped there where it never sees the sun. And then the other advantage, especially if you want to build a moon base, is that parts of the South Pole on the rim of those craters can have sun about 90% of the year. So if you want to build a moon base, and you can put a big solar cell collector there, a big solar panel out, and you then have sun year round. Because if you're at the equator, you get sun for 2 weeks, and then you get darkness for 2 weeks. So it would be really hard to put a moon base on the equator when you have 2 weeks of night, and that's a lot of batteries you'd have to have there. So the big advantage is, number one, science, but then number two, just the sort of the physics of it and being able to have sun almost all the time, so you can actually have a base there and rely on solar power to support the base.
Great. So we have a question that came in from Val over in Springfield, Oregon. How do they come up with the names? And Val, you can let us know, but I think you may mean in terms of what they call the rockets, the segments, and all of that.
So a lot of the names, as you can see, NASA, as with many things, relies on, Greek mythology and the constellations and things that people are familiar with. So Artemis really was, it came up, the folks at headquarters, the communications team and the program management types, they actually came up with that name for Artemis being sister of Apollo, right? They had the whole story behind it. Some of the other vehicles like Orion, I think they just picked the name. Someone up at the beginning liked it. I never got quite a story of why. But some of the other names, like the rovers, they actually run essay contests for. So, there's been essay contests for students to suggest names. Perseverance, which is the new Mars rover that just launched in July, was named that way. There was an essay contest with kids. Kids wrote in different name suggestions, and then they picked the best one. So Perseverance was named by a student, I can't remember what state. I want to say it was Minnesota. So a student from Minnesota named the Perseverance rover that just launched and will land in February on Mars. So there's a variety of ways. The big human spaceflight programs, the agency names themselves, but some of the other things like the rovers, they'll run contests for. Obviously, they only pick the good names. I like Perseverance. That was a good name that they picked. But yeah, so it can vary on the names. Great question.
And I think this question actually, I think it's from Jenny in Eau Claire, Wisconsin at Heatherwood, if I'm not mistaken. How many other countries are involved?
Awesome question. So on the International Space Station, it's called international because I believe there's 13 different countries involved on that. A lot of the partnerships working with other countries that we learned on the space station, we can keep those partnerships going forward. And in fact, Orion, which is the vehicle for Artemis that will carry the crew, is partnered with the European Space Agency already. So the service module portion of Orion, where the solar arrays, the main engine, and the propulsion tanks, and several of the equipment in the trunk, if you will, of Orion, is coming from the European Space Agency. And so that includes 10 European countries in ESA. I can't quite remember, but so I actually had many trips to Germany and France, and I didn't get to go to Italy, but the Italians, Spain. So a lot of Europe is actually already helping on Orion. In terms of the Artemis program going forward, we're already having engagement with the international partners. Europe wants to build a habitation element for the Gateway. JAXA, the Japanese Space Agency, is looking to build a pressurized rover. Canada is building a robotic arm. So a lot of those lessons learned building the International Space Station are already carrying forward into Artemis. So whereas Apollo was only the US going to the moon, we're going as a coalition of nations again for Artemis. So when we go to the moon, we're actually going with a whole bunch of countries contributing elements, and eventually, hopefully, some other countries' astronauts as well. So a lot of countries are involved. It's one of the best things about our job is that we get to do this in partnership around the world. And so we are carrying those lessons forward in Artemis.
Nice. Actually, kind of a follow-up question to that one that I'd like to throw in the ring is you mentioned several parts being manufactured in different states. Do you have an idea of how many different locations or states are even contributing to the manufacturing of the vehicles?
So that's an awesome question. So I think I saw just a couple months ago that they actually filled in the last state. So all 50 states have something that's actually being built, because when you think of these vehicles, they're huge, but they need to purchase a lot of their components and equipment. So everything down to the solar cells, the sensors, the software, and the computers, all of those things are purchased from around the country. So I actually think we've actually hit all 50 states end up having some supplier that's sending something in for the vehicles. So it is really important, right? The NASA centers are spread out around the country. The big projects, just because they touch so many things, end up involving so many states. So there is a website somewhere that has it. I might find it and send it to you, but you can actually look up what's being contributed in your state for Orion and the Artemis program. So really not just the countries, but the whole US is contributing to this. So it's really fun on a call like this where we've got so many states represented too. Your states are all sending something in for this as well.
Good news. Privately, we have a couple of us who would hope that we could submit the name Compass for one of the vehicle names. So we'll put that on the burner there.
There you go. Stick it in there.
We do have a couple more questions, actually. SpaceX's reusable rockets are not currently up to launching a mission of this magnitude. However, is the idea of a reusable rocket out of the question for a mission this large with our current technology? And how far away are we to more reusable technology in the future?
So that's an awesome question. So yeah, SpaceX and SpaceX is a partner of NASA, right? They're a contractor we use. If you've been watching the news in May, SpaceX just started sending crew to the space station for the first time from US again. So yeah, we contract services from SpaceX, and they are able to use some of their rockets. So that technology is fairly well understood at this point. But as you point out, it's not up to this size. And that's really one of the big challenges in reusability, is that in order to actually recover the rocket boosters, it takes away from the performance of how much it can put in space. So when you actually recover the rocket, it takes up about half of what was the performance getting to space. So even for SpaceX, if they dispose of their rocket, they can put more things into space. So with SLS and Orion, it takes a lot of stuff to go to the moon. It takes a really big motor. So all of those things. So we're not reusing SLS because we're trying to get more stuff into space. So it puts 26 metric tons into orbit. So there's quite a lot of stuff, and that's just Orion. That doesn't include the booster that puts Orion to the moon. So there's a lot of stuff SLS is getting into orbit. So that's why we don't reuse that rocket. But I think as things go forward with advances in technology, we might be able to see more reusability. The big challenge is all the humans don't get smaller. As satellites have gotten smaller over time with microprocessors and better computers and stuff, you can reuse those rockets. It's fairly easy, but with humans, you just always need a lot of stuff. And so that's why we aren't reusing the rocket. But hopefully, SpaceX is working on some really interesting things like the Starship, and that should be reusable if they can make that work. So there might be other techniques in the future that we just don't have yet.
Great, thanks. So I do have a few more questions too. Although I think we've got about 5 minutes left, but we can probably get there. This actually comes down from Majestic Rim and Payson, Arizona again, I think. Is there a public or private sector included in the future plans? Oh, Suzanne Jones is asking. Is there a public private sector included in the future plans? I'm not sure if I'm clear on that question, but.
So I'll answer it as best I think. So all of our vehicles are built by private companies, right? NASA as a government agency is sort of the owner operator for the most part, but we purchase them from the private sector. So Orion is built by Lockheed Martin. The Space Launch System rocket is built by Boeing. And then we've got a lot of partners like SpaceX doing commercial crews. Other rockets send the the United Launch Alliance rockets send the rovers to Mars. So there's a lot of private sector companies that support NASA. They're our contractors. But then a lot of what we're doing is also enabling open architectures in the future. So, and one of the big things with the human landing system, as I mentioned, there's 3 companies competing with it, is we really have changed the way we're working with the companies into more of a commercial procurement. So with SLS and Orion, NASA was very involved in the design and some of the decision making and stuff like that. With HLS, we're trying to give the companies more leeway. So it's more of a procurement model where we just say, I need you to land the crews on the moon. It has a very limited set of requirements, and show me what you got, essentially. And so the 3 designs proposed from the different contractors are all very different designs, but they would all achieve the mission. So we are going to more of a commercialization in that manner. And then a lot of the technologies we're doing are going to be sort of plug and play in the future. So we can write a spec, and if someone else could launch cargo to the moon, we may pay for that service. So eventually we're trying to bring along the commercialization programs with us. So it is a good question. And yes, we're trying to lean more into commercial systems in the future.
We do have another question from Lassenhouse in Red Bluff. Are there any diseases up there? Is that why they're so protected?
So during the times of COVID, as we are all very familiar with, right? So the astronauts do have to quarantine just like we are before they launch, because if they take, it's not that there's more diseases out there, it's more what you bring with you. So if you bring the flu with you to the space station, you're very easily going to give it to everyone else on the space station. So the astronauts are quarantined before flight so that they don't have any communicable viruses before they go. And then we'd have to do the same thing when they go to the moon. And one of the biggest risks in human spaceflight is that the people, the astronauts themselves, get hurt or have a medical emergency while they're there, because it will take days to get them home again. So when you go to the moon, when we go to the space station, they can be home again in a few hours. So if there's a true medical emergency, they can get down to Earth within 3 to 6 hours. And it's only 45 minutes literally from space to the ground. When we go to the moon, it's going to be 5 or more days, and in most cases 11 to 14, before they can return if they were on the surface to Earth. So it's really important that we are sending only healthy people right now, because if they get sick while they're there, even if they just fall down and break their arm, they are a long way from a big medical care. So it is very important that we keep the astronauts safe before they go, so they don't have any diseases when they leave. They shouldn't catch anything once they're there, because there's no one else to give it to them.
So I think we have one more question, and everybody's been saying, thank you so much. This is really exciting to get to hear. And maybe this is an appropriate question then. How can the public like us help fund and support this and future missions?
It's not an inappropriate question, but truly we are a government agency, right? NASA is a government agency paid for by your tax dollars. So literally the answer is that this is a service for the country, and you need to write and call your congresspeople and tell them that you want more NASA. It literally comes down to that. So we get our funding. We are authorized by the congressional budgets and the presidential direction. We serve all the administrations. So the purpose of writing your Congress people does have an impact. We serve at the public's will, and we need congressional support to do that.
Sounds like a great plan. And I think, so that was all the questions asked in our chat. I think several people have come in on the chat just saying, thank you so much for your time and for this exciting opportunity for everybody to get to participate. Thank you everybody out there who throughout our company that actually joined us today. I'll let Najud say any final thoughts, but also wanted to put in a plug for our next session, which is actually going to be on October 20th. And that's going to be with Dr. Cynthia Evans. And she is going to take us through what it's like to hunt for meteorites in Antarctica. I'll get a little bit more detail on that and send it out to you guys. But please join us again, same time on October 20th. Najud, any final thoughts?
I appreciate having me today. It's really fun and lots of engaging questions. So I hope you enjoyed it. I really love what I do, and it's even more fun when we can share it with the public. So thank you.
Thank you. Take care, everybody, and we'll see you on October 20th.